Hello, Alan Shura again here, July 23rd, 2017, and as you can see here I have just one of the motors that I had in the previous videos. In this I want to show the output of the 4.5 volt 1.5 amp maximum 6.75 watt AC adapter connected here, and I also have a diode, 6 amp diode. Used one of these brand new diodes, and now I will connect the power. Here's voltage, there's amperage, and so normally it would be like 4.68 volts, but it exceeds the 1.5 amps, and in fact it doesn't have enough power to start the motor. And it's the same on this motor. So now I'll have to put this unit back together again, and so that just shows that there's not enough power that the AC adapter puts out, but it does put enough power with the circuit, so we'll see that as well. Like so, you know, I have a background in programming, and I've worked in power plants for a long time, but I'm not an expert at everything electronic, and so it's a large field, just like computing. You rely on people who spent a lot of time learning different aspects, because the technologies of today, industrial technology, any organization, it's multidisciplinary. So this is why organization is needed. So I may try some crowdfunding soon. But anyway, we'll get on with the test. And so here, again, we use the, here we're going to limit our power with the AC adapter, so we're not using the power supply. And we know that this particular AC adapter limits the power supply very well. When it's an open circuit, it puts out 4.68 volts. I have a number of these AC adapters too, and a lot of them work just as they are intended, and they do limit the power. I found that not all AC adapters can do that. And we're also going to use a diode, so that to ensure that the power flows in one direction. Someone suggested maybe the adapter could get hot or anything. I haven't found that to be the case. So, and someone suggested that voltage regulation may be out in the power supply. Well, it can't be 100% discounted till we work with a number of power supplies. I'm not at that point yet. This is part of the reason for trying to get crowdfunding to organize for this. Okay. Okay, it won't even start, but you can see the amp gauge has gone wild, and I trust this more than the power supply one. The power supply seems like it's measuring reactive power, but the amps always seem higher. Anyway, this is only supposed to put out about 1.5 amps, and with the pulse it is just not working for the motor. It's trying to start, but it can barely start. It starts and stops. Now it's stopped. And a lot of things, as I say, can affect this. Like, not only is the motor getting a little worn, but different pressure on your mounting can affect this too. If there's too much pressure on the shielding of the motor, then it can cause a lot of extra friction, requiring extra power. And the same goes for how well aligned these are. So anyway, that's all the power that this AC adapter will put out on those. And how much power will the AC adapter put out on some lights? We'll go back to these 26.9 watt light bulbs. And we'll switch the power to them. Okay, so there's one light, and the amperage there on the constant light is just below 1 amp, about 0.9 amp, but around pretty close to 1 amp. And so then we try a second light, add it to it, and if you add it this way, well, there it starts blinking. It's blinking, and so it's too much power now for it to work constantly. But you can see it's blinking just over 2.25 or 2.5 amp at the peak pulse of the current that's trying. But there we have resonance. Now when we get resonance, both are lit, no blinking on two bulbs. And we have a constant amperage of, well, it looks like and that's with the two of them. Now that they've the wave has bounced back and forth there. See, when it catches the right impulse of a wave, the light can resonate, but it cannot as easily get three of them lit. In fact, I'd like to be a little more precise there. A little tighter grip there. It's really difficult to get three lights going, that's for sure. There I can get three lights going like that, and well, I can tell you from experience that I've tried a number of times and I haven't been able to get three of them to go constant. And so again, you can see the fluctuation in the amperes on the amp meter. Okay, so that's about the limit for this AC adapter, and it's So what it says is 4.5 volts, 1.5 amp, 6.75. Probably can't see it. So I'll go to the next part of the video, and so there'll be a number of controls in this test, and so you'll see it next operating with the circuit, and the circuit will provide much more power. And just so we can recap here, the motor did not run just off of the AC adapter, limiting the power supply that low, which is an extremely low voltage, maximum 6.75 watts. But I found that on the lights it can take out as much as 8 watts with 2 amp at 4 volts. It drops from about 4.6 to about 4 volts, but we'll skip that. And I'll try, and I have a website now, shuraenergy.com, and I'll try to post some of the data there, or I will post some of the data there after posting this video on YouTube. So shuraenergy.com, check for that. And we'll get on to applying the circuit, which is one of the two effects, the circuit and the acceleration. But at this voltage level we are well below the threshold of acceleration. I know that this is a lot of information to absorb, so the viewers should go to the earlier videos to get up to speed on everything, and there is a lot of theory but I'm showing just the effects and the tests, and there's a lot of potential here, a lot of practical potential, so I'm moving forward with it. And now I'll show it this very low power on with the circuit applied, though it'll be too low probably for the acceleration. Hello again, everyone. Yeah, I have the circuit running here, and it's going through a diode, 6 amp diode, and through the amp meter it's showing a little over 2 amp, about 2.1 amp. And the output is 2 light bulbs, the same light bulb, plus the motor is running very strong. This is all off that AC adapter on the wall. Well, it's 4.68 volts open, so we'll test the voltage here. And the voltage is at the output 1.82 volt. And at the input here, .26 volts, 4.26 from the AC adapter. And at the output, maybe I didn't get that in solidly enough. We'll just test this again. Oh. 1.81 volts. This is with a single light. With a single light, 1.81 volt. It's showing 0.55 amp. And it barely even slowed down the rotation. So we moved to 1.11. 1.1 amp. The input. About 1.9 amp. Less than 2 amp. Here we will summarize everything that we have seen in this video. This was a test to limit the power supply to the renewable energy generator or engine motor generator, and we limited that with a AC adapter. So at this low voltage we did not get the accelerative effect, which there's a threshold of acceleration in the previous videos. We are just testing part of it because that effect does not occur till about 17 volts or so, and this is 4 volts, 4.5 volts, 1.5 amp, but we've seen that it puts out a little more than that, up to about 8 amp, or I mean not 8 amp, but 8 watt. So this technology has a lot of potential. I have the website shuraenergy.com, and I may have to form a company to organize the research and advancement and distribution of this applied DC circuit, which, if there is extra electromotive force, was very useful in this time when we're seeing more and more electrical vehicles. And there's a similar arrangement they even used, you know, with EV motors for with 2 DC motors, but not the circuit or the same configuration quite. But this is very adaptable because industry produces many motors like this, and it only, as far as I know, it only works with a permanent magnet motor. But this is what the research is all about. Like, we have to find out the torque to see the increase in torque, and we have to test with bigger engines. And possibilities, well, there's quite a few possibilities. Maybe it produces HHO more effectively because of the increase in power, but to find ways to convert the power out is what the research has to be directed toward. And so it takes organization, and that's what the website is about, and what the potential crowdfunding getting underway here, 2017, is about. And there's numerous forces in here. I mentioned one, you know, angular momentum. Other people have mentioned back EMF, Lenz's law. They're all combined. They're combined in this configuration. And there's some new theory about electrical waves, standing waves. So it takes time and organization to do that.